line yet?
No, I don't see him.
Okay.
Do we want to wait?
If he doesn't come on by the time it's his turn on the agenda, we can just rearrange things.
It's okay by me.
Okay, with that, I think we can get the show started here. Oh, lost my agenda. So I'll start with just a quick reminder right now for everyone to mute your phone or computer or both if you're on both. I see some of you are not muted and there can be background noise that's pretty distracting. So welcome everybody to the August Lowry CAG meeting. Just the usual housekeeping. As I just said, be sure and mute your phone or computer. You can, on the phone, it's *6 to mute and unmute. If you would like to speak, remember to introduce yourself first. Well, most people are on the screen, but just in case, you know, let us know who it is. And then be sure and mute again when you finish. You can also, there's an icon for chatting at the bottom of the screen. If you move your cursor, you can send a question and Janine will monitor those. And a question or a statement or to point out that you want to say something. And you can, let's see. I think that's all the housekeeping. Anything else, Janine?
No, I think you got it all. Yeah, I will be monitoring chat, so please feel free to use that, and I will relay and find good timing for things for either you to speak or for me to ask your question for you, whichever you prefer. Thank you. And David Berry is coming on right now.
Great. Okay, so I'll hand it over to Linda Kiefer, who has a few site updates.
I hope everyone's having a great day. I know the smoke in Colorado is pretty irritating a little bit, especially to my lungs, but hope it's not bothering you too much. And welcome to all the new people who are on the call. I just had a few side updates with the CAG facilitator. I know it's been a long time that we've been trying to acquire one, but I don't have any new news that's different from what I said in July. We're still hoping that we'll have he or she available for September, but I really don't have any change on that one. The next update is the draft conceptual site model, which covers the Lowry landfill area, is undergoing review by the agencies and the WSDs. This is taking longer than we expected, which means the public review period where you can provide comments is expected to start now in September or October versus August. And my last update is that EPA did receive the CAG surface water data review report authored by McGinnis and Associates. EPA is reviewing it and will provide a response. And that's all the updates I had. Any questions?
Okay. So Dr. Berry, you made it on the call, right?
I've muted everyone, so we kind of need to remind people to unmute themselves.
David, can you unmute? Are you there? Oh, did you see him sign on?
I did. Let me look at the.
Yeah, it says he's on. Maybe he didn't know it would come up this fast. Let's see.
Bruce, you're still, no, not Bruce. David, right? David, you're no longer muted on our end. Are you muted on your end?
I might be. Am I unmuted now?
Yes, you are. That's
Yes.
better.
Okay.
Okay, David, do you want to share your screen for the PowerPoint?
Okay, hang on. Let me pull this up. Well, let's see. Wait a minute first. Shh. Okay, so we're working on it.
Hey, well, while you're working on that, the person on the phone with the last three digits, 257, can you identify yourself, please? I think it's somebody that was on before.
It's not letting me share my screen.
All
You
right.
clicked on the share screen at the bottom and it's not working?
It says share my screen, which is green, and I turn on to that, and it gives me Jeannie's screen, and then it.
Do you want me to go ahead and do it for you?
Sure.
Okay, let
It
me
doesn't
put
look
that.
like.
Hold on a minute, I gotta go pull it up. I didn't have it up on my desktop here.
Hey, Janine, this is Margie Sobey.
Sure,
While
Margie.
we're waiting, I'd just like to make a comment.
Sure.
If whoever, I'm so glad to have a lot of people on the call, so don't get me wrong about that. But if someone won't identify themselves, are you able to just terminate them from this call?
I am. It turns out that 257 number is actually, I think that might be Keith Homersham. He was on before and I guess he dropped off for some reason. So I think we're
Okay,
right.
looks.
Go ahead.
No, mine is 650, Jeannie.
Well, it's somebody that I've already identified because they came back in and they have a name. So it's one of the other folks.
And
think
so
it's Lynn.
which one
Is
of
that
the other
Lynn?
folks?
I think that's Lynn, yeah.
Yeah, I think she was the second person you talked with.
Okay, thank you.
Can folks see that? Can you see that?
So is my screen up?
Can people see? I'm sharing. Can you see the screen?
The
Yes.
PowerPoint did come up. Mhm.
David, do you see it?
We can see
Yep.
it.
Okay. All right. Take it away.
Take it away. Okay. Well, I'm going to give a kind of a brief talk on risk assessment and the risks associated with the 1,4-dioxane plume. This particular picture happens to be a picture of Vermiculite Mountain, which is just outside of Libby, Montana. And I've spent the last 13 years working on that Superfund site. So why do we want to do a risk assessment and what is it? Well, it's a consistent process that we use for evaluating and documenting public health and ecological threats associated with a hazardous waste site. A couple of some introductory kind of pieces of information. A risk assessment basically is a tool that uses science and science policy assumptions, and it's a tool we use to support risk management decisions. And risk management basically manages the risk by taking into account the implementability, effectiveness, and cost of the remedy. A risk assessment is not a study of health conditions that you already have. It's not a medical examination. It's not a recreation of ways you might have been exposed to contaminants in the past, from industrial, environmental exposures to current environmental exposures. And it's not a study that will tell you directly whether or not existing health problems you have were caused by past contact you may have had with chemicals associated with the Lowry landfill. Risk assessment is a comprehensive study that we use to evaluate ways persons might come in contact with 1,4-dioxane. It's a calculation of how likely human health effects might be occurring from future current or future receptors because of, in this case, 1,4-dioxane in the shallow groundwater. It's a way to identify potential health risks. It's a tool we use to assist the EPA in protecting human health and the environment. And it's a way for EPA to determine whether or not shallow groundwater, in this case out here in the North Boundary Plume, needs some form of environmental response. The objectives of a risk assessment basically are to help determine the need for action at the site, provide the basis for contaminant levels that are protective of human health, provide a basis for comparison of remedial alternatives, and it's also a process for evaluating and documenting public health threats. And all of these are required elements in the National Contingency Plan. There's 4 basic steps associated with risk assessment: data collection step, an exposure assessment step, a toxicity assessment, and then characterization of the risk. And I'll briefly walk you through each one of those processes. So we'll start with a data collection and evaluation. Here, data is collected after a quality assurance project plan has been approved and a sampling plan. We have a site investigation. In this case, we had a bunch of monitoring wells installed out there. And the site's characterized, the data is analyzed, and we determine what the chemicals of potential concern are, and that's what COPCs are. And in the case of the shallow groundwater out here in the North Boundary Plume, the major constituent of concern out there is 1,4-dioxane. And as Tom and his question asked about, why aren't you considering the other compounds that are out there? And that's a good question, and that's an oversight on my part. And so we've added in the other chlorinated solvents and naphthalene that have been detected out there, and EPA and the state are currently reviewing those risks. So during the site characterization, we sample the environmental media, which and can be soil, groundwater, sediment, surface water, soil gas, air, and biota. And in the case of the North Boundary Plume, we've sampled the groundwater. Chemicals that contaminants out there in the North Boundary Plume, we've analyzed for VOCs, nitrates, major anions, and cations. The methods are provided there in the parentheses. And we have 1,4-dioxane in the shallow groundwater. We also have 1,4-dioxane in the surface water. And as I said, we're currently working with CDBHE on incorporating the VOCs into the risk assessment. And this will be done, in the near future. So we'll move to an exposure assessment. Here we develop a kind of quantitative exposure dose. And in order for us
Dr. Berry,
to...
can I interrupt you a second? Which slide do you want me on? Which slide do you want me on?
Oh, this is not advancing as I'm going through it?
Well, no, because I'm doing it. I don't know where your natural, where you want things to advance.
Oh, boy.
Yeah, you have to say next slide, please. Next slide, please.
Okay, so I didn't know, I thought I was able to advance it. Okay, right now I'm on slide 13,
Which says, I don't have numbers on these.
a completed exposure pathway.
Am I going the right direction? Oh, here. There?
That's right.
Okay, thank you.
Okay, so I'll tell you when to advance the slide then.
Yes, please, thank you.
I thought that I was sitting here advancing the slides, and so I'm sorry about that. So a completed exposure pathway consists of a source and mechanism of chemical release, a transport medium, and in this case it's the groundwater, a point of human contact or exposure point, and that could be a human potential future hypothetical resident, for instance, and an exposure route at the contact point. And you need all four of those components in order to have a completed exposure pathway. So let's go to the next slide. And this slide illustrates what an exposure route is. Our little guy over there can be exposed to gases and airborne particles via an inhalation pathway. He can be exposed, he or she can be exposed via ingestion of soil, groundwater, or food. And finally, they can be exposed via dermal contact with soil and water. So that kind of gives you an idea of how humans might be exposed. Let's go to the next slide. So how do we calculate chemical intake? Well, this is basic algebra, I guess. We have a chemical concentration in the water, whether it's, in this case, shallow groundwater or surface water. And then we make some assumptions about an intake of that groundwater. We estimate the exposure frequency and the exposure duration. And then we divide that by body weight and the average exposure times. And that gives us a time-weighted dose of chemical that the individual's exposed to. So we have a whole bunch of exposure assumptions, like in exposure frequency and exposure duration, and I'll talk about those in just a couple of minutes. So the next slide is in estimating exposure to chemicals. We utilize the concentration of the contaminant in groundwater. In the case of 1,4-dioxane, it's quantified in micrograms per liter. And the exposure point concentrations do not change with the population that's being exposed. And for this particular site, we've calculated exposure point concentrations, which are concentrations that we use to represent the concentration that our receptor might be exposed to. So in the case of a theoretical resident using the groundwater for potable use, the groundwater concentration is 2.9 micrograms per liter. For our other folks who are associated with surface water exposure, we have a groundskeeper who's exposed to surface water, and the concentration that we use for the surface water turns out to be 1.9 micrograms per liter. And you're probably asking, where do these numbers come from? These are are statistically derived estimates of an exposure point concentration using, for instance, all of the data from the monitoring wells out there in the plume. And we calculate what we call the 95th percentile upper confidence limit on the mean value. So these values are greater than the mean concentration. And we refer to this concentration as a reasonably maximally exposed individual concentration. So it's an upper estimate of what one exposure might be. So these values are statistically derived. And so as I said, the groundskeeper is exposed to surface water, and the surface water concentration is 1.9 micrograms per liter. The golfer who's potentially exposed to the surface water, again, 1.9 micrograms per liter. And the adolescent who might be crossing the stream or playing in the stream is again 1.9 micrograms per liter. Next slide. So we're going to talk just briefly about the toxicity assessment. There are two concepts that we deal with as far as toxicity of environmental contaminants. Two categories of chemicals which are not carcinogenic, and these chemicals are believed to act via some sort of a threshold mechanism. And this means that there is some level below which it's unlikely any sort of adverse effect might occur. And above that threshold, an adverse effect might occur. In the case of carcinogenic chemicals, these chemicals are we believe to act as a non-threshold mechanism, and that is that there's a risk associated with any exposure level. In the case of 1,4-dioxane, it's a carcinogen. Originally, it was believed that it was a non-threshold carcinogen. There's now evidence to indicate that at least the liver tumors that 1,4-dioxane induces in laboratory animals is probably a threshold phenomenon rather than a non-threshold phenomenon. So the next slide kind of gives you a pictorial, if you will, of the threshold toxicants. And you can see the graph up there, and we have a x-axis, which is the concentration of chemical or dose, and the y-axis is the response. And we see that line going off to the right of the y-axis, and that distance between the y-axis and the incident of the line is the threshold area, below which there is no adverse outcome associated with exposure. And these values are determined, using either human epidemiological data, or more often than not, laboratory animal data. So the toxicity factors for non-carcinogenic chemicals are usually determined by rodent bioassays. The next slide shows a dose response for non-threshold chemicals, and here you can see that the graph goes through 0, and the y-axis might be the incidence of tumors, and the x-axis, of course, was dose, and with increasing dose you see increasing tumors. And unlike the non-carcinogenic toxicity factors, which use some sort of an uncertainty factor, risk factors used to assess carcinogens do not have an uncertainty factor. So let's go to the next slide, and we'll talk about risk characterization, and we'll, I think, focus in on the results of the risk evaluation for the north boundary plume. And this is just to remind you that we calculate two kinds of risks. A non-carcinogenic risk, which we refer to as the hazard index, and hazard index is the sum of hazard quotients that are calculated for each compound. And here we only have one compound that we're dealing with in this particular assessment, so we're going to talk about the hazard quotient. And the hazard quotient basically is calculated by estimating a dose, which is a function of the concentration and the calculated contact time with the receptor. That gives you a calculated dose, and that dose is then divided by an acceptable dose. And the acceptable dose comes from toxicology studies, which define what the acceptable dose is. And if the hazard quotient is less than 1, it considers that there's not a possibility for adverse health outcomes. If the hazard index is greater than 1, then the possibility of adverse health outcomes increase.
Janine, can you advance? I think it's supposed to be on the next. Yeah.
Okay, so then let's go to the next slide, which is risk characterization for carcinogens. Here the goal is basically to calculate a theoretical cancer risk. And this is done by taking the cancer slope factor, which again comes from toxicology studies, and multiplying that by the calculated exposure, which comes from the exposure assessment, to give you a calculated risk. And this risk is usually expressed in some form of exponential value that's a probability. And so calculated risk might be 1 times 10 to the minus 4, for instance. So that's how we basically calculate potential cancer risk. Let's go to the next slide, which tries to put this into perspective as far as the risk spectrum. And if you look at the 2 vertical bars in the middle of the figure, that range in between those 2 bars is the range that is considered the acceptable risk range in the National Contingency Plan. And this range goes from 1 in a million, which is the left vertical line, to 1 in 10,000, which is the right line. And risks that exceed the 1 times 10 to the minus 4th, 1 times 10, 1 in 10,000, that's considered an unacceptable risk range, and some form of action is required. For risks that are less than 10 to the minus 6, which is the green side over here, those are considered acceptable risk ranges and no further action is required. The risk management range is a range that within this particular area, risks are, some sort of risk management is not necessarily required. It depends on a number of site-specific factors as to whether some sort of action is required in that range. The other thing that we need to point out, I guess, is the issue of non-cancer risks or hazards. The hazard index, a threshold is 1, and if the hazard index is less than 1, it's considered acceptable. If it's greater than 1, it's considered that some form of adverse health outcome might occur, and some sort of action may be required. So this arrow, two-sided arrow, kind of tries to put the risks into perspective as to action on one side and no action on the other side. So I think the next slide is a slide that gives you the calculated risk for a future resident at the within the north boundary plume area. So we have ingestion, inhalation, and dermal contact. And the inhalation occurs from bathing in water that contains 1,4-dioxane. So the future resident here is a combination of a child and adult, and the child is exposed to these materials for 0 to 6 years. He or she ingests water, bathes, and has dermal contact, and then we add to that the adult exposure, and the adult exposure time is 6 to 20 years, and so we have a total exposure period of 26 years. And when we do this, the risks that we calculate for ingestion of the groundwater is 4 times 10 to the minus 6. For inhalation, it's 2 times 10 to the minus 6. For dermal contact, it's 1 times 10 to the minus 8. You sum all those up, and the total cancer risk is 6 times 10 to the minus 6. That's 6 in a million risk. And turns out that the hazard quotient for this turns out to be 0.03, which is acceptable. And the 6 times 10 to the minus 6 risk is also within what we would consider the risk management an acceptable risk range. So the next slide deals with the groundskeeper. And here the groundskeeper is exposed to surface water while they're working on the golf course. And I got some information from Eric Stanished, who's the head groundskeeper out there, as to some exposure assumptions. So we made the assumption that this groundskeeper works out there 250 days a year, 6 days a week, for 6 hours a day, and he does that for 24 or 25 years. And when you use those assumptions and calculate a dose, and then calculate the risk, his risk for incidental ingestion of water out there is 4 times 10 to the minus 7. Dermal contact, and we're assuming that he's contacted the surface water from hands and the forearms and his feet and lower legs. That risk is calculated at 1 times 10 to the minus 9, and you sum that up, and his total theoretical risk out there is 4 times 10 to the minus 7, which again is within the acceptable risk range. And the hazard quotient for the groundskeeper as you can see there, is 0.0003. So that's very low hazard index or quotient. So the next receptor that we analyzed out there is the golfer. And again, we got information from the groundskeeper out there about the golfers and what a likely exposure scenario might be. And so we've made the assumption that the golfer is out there, I think, 45 times a year. And he is on the course for 6 hours a day. And he incidentally ingests a small amount of water. And he comes in dermal contact with the surface water. And when you use those exposure assumptions and calculate his dose and then calculate his potential risk, the risk from incidental ingestion of water is 5 times 10 to the minus 9. The dermal contact risk is 2 times 10 to the minus 11. And when you sum that, it's 5 times 10 to the minus 9 as his theoretical cancer risk. And the hazard quotient, as you can see, is 0.0005. So again, both of these are within acceptable risk ranges. The next slide, I think, deals with the adolescent who comes in contact with the water out there. And we assume that this is a person from 6 to 16 years of age, and that they contact the water and the surface water in Murphy Creek, and incidentally ingest water and are dermally exposed. And we assume that they do that for 10 years. So when we calculate using those exposure assumptions, we can calculate a prorated dose. We then use the dose times the risk factor, and we come up with a calculated risk of 9 times 10 to the minus 9 for ingestion of the surface water. And dermal contact, the risk is calculated out at 6 times 10 to the minus 10. And when you add those up with rounding, the risk comes to 1 times 10 to the minus 8. And again, the hazard quotient is very low. So these are also in the acceptable risk ranges. So those are the receptors and the theoretical risks that we calculated for exposure to groundwater for a hypothetical resident out there, and for the groundskeeper, golfer, and adolescent that might be exposed to the surface water out there. So what we've estimated, basically the risks for exposure to groundwater and exposure to surface water, and all of the estimated risks that we have calculated out there are within what we consider the acceptable risk range as defined by the National Contingency Plan. And that is a risk of 1 in a million, which is 1 times 10 to the minus 6, to a risk of 1 in 10,000, which is 1 in 10,000. And I think the next slide says points to remember. And what we want to take home message here is that the risk assessment that we've conducted out here uses science and science policy assumptions, and we use those to estimate risk. And then in order for risks out there to approach unacceptable levels, the groundwater concentrations would have to be at or greater than 46 micrograms per liter. and that the risk management that's going to occur out there manages the risk by taking into account, the implementability, the effectiveness, and cost. And I think that's the end of my little risk assessment presentation, and I will be happy to entertain and try to answer questions that you might have.
What we're going to do is, apparently Steve Wharton has the floor in a minute, and that's because he's going to speak to concerns the CAG have specifically. So there are questions in the chat box, but we're going to let Steve go first, and then we'll address the CAG's concerns or their questions for tonight. Does that sound okay?
Steve, are you
Yep.
available? Steve Wharton?
Yes, and whoops.
Nope, hold on.
Okay, I see myself. Hopefully other folks see me.
Yes, we see you.
Yeah, we can see you.
Okay, and you can hear me, obviously, it sounds like. Great. Well, part of what I wanted to say does fit here. Part of it we may need to circle back to a little bit later, and I do want to get to the questions that came up during David's discussion. And the point of me interjecting a couple of comments here were just reminders, basically, that the the CAG over quite a few months has expressed concerns about us, EPA, CDPHE, focusing just on one area of the site as opposed to looking at it holistically. And I wanted to reassure folks that that's not the case, that we still absolutely look at the site in its entirety. The 5-year review, which becomes a focal point, a roll-up of issues from across the site, is a site-wide activity that's dictated by our policies and how we approach that process. It's intended to look at remedies for all parts of a site where in fact you've implemented the remedy. As you well know, it takes time for especially larger sites for us to deal with all parts of it. So we may have several records of decisions, several remedies that take time to implement. So we'll look at all those that are complete. The ones that are still ongoing, of course, we don't until we get done with those. So at the same time, the 5-year review does try to boil down the things that need further attention, and we call those issues and recommendations. And those are the things that we've been working on collectively here for quite a while. So, again, part of my message is just that even though we're pretty far down into the details of talking about the north end, talking about, at this point, just 1,4-dioxane, there's more discussion, that we hope to have, intend to have. And so I just didn't want folks to get the sense that now that we're talking about this, that this is the last and final word on this. And we understand that's not the case. It's hopefully contributing to a dialogue about these issues. And so, we thought it was very important to get this information in front of you. I know it's a lot of math, a lot of numbers, formulas and things like that. But the other part of what I wanted to say is perhaps the part that may need some further discussion later this evening or in future meetings. And it gets to the point I had tried to make. Gosh, I think this may go all the way back to the last one of the last in-person meetings that we might have had, where I tried to identify why we were talking past one another, essentially. And we were doing a lot of talking, that's for sure. But we were not reaching that middle ground that we were hoping to get to. So, again, now that we've got some data, we've put some math to it through the risk assessment process. We believe that means something. And this is the point at which we need to try to reach that resolution about, well, what does this mean? What does it mean to us, the regulatory agencies? What does it mean to you, the community, and start that dialogue. And so that's the second part of my message, I guess. And I'll leave it at that for now. And again, I'm going to be here, obviously, for the whole meeting. We can address the questions and comments that came up during David's talk, and then if there are other related comments, great. We can talk about those. That was it for now.
Thank you, Steve.
Janine, Tom Kraus, I was wondering if I could ask a question.
Absolutely.
Sure.
Okay. Dr. Berry, I think the most important thing you said was that the 46, at least for me, the 46 micrograms per liter of 1,4-dioxane would have to be the concentration of which would cause toxicity to somebody who was in the pathway of the plume. Is that correct?
That would be the level that would lead us to a unacceptable risk range.
Okay.
And just because you get to that level does not necessarily mean that there's going to be an adverse health outcome.
No, but it's still
it just increased. It's just a probability of 1 in 10,000.
All right.
Okay.
Yeah. Now, that being true, to me, it puts my mind at ease somewhat, the fact that at Jewel Avenue, we have 3.6 micrograms per liter right now, or at least we did in the 2019 O&M report, at a point that was just across the street from the Murphy Creek townhomes that have been left off of the map so that we can't see that they're right next to that test point, or for whatever reason, but that's what's the outcome is. I would think that, that would take at least, we're not even close to that 46 micrograms per liter. Otherwise, I would be asking EPA and WSDs, why aren't you putting wells up Old Tom Morris Road and along Jewel Road to the west in order to see whether or not there are contaminants coming into the townhomes there. And I think that you might consider that if you really want to have good relationships with the people in the townhomes, so you can kind of guarantee as much as possible that there's not that much 1,4-dioxane going in there. That being said, at the north boundary barrier wall at PTP 25, you have 690 micrograms per liter of 1,4-dioxane. Just north of that at B, let's see, there's another one just north at B307 that has 100 micrograms per liter. And B3112, that's just a little bit further north of that, has 74 micrograms per liter. So all of those are concentrations that are of very much concern if you were living right there, and you're not. But I think that EPA and the WSDs have an obligation to explain to us why those 1,4-dioxane concentrations are there when nothing's supposed to get beyond the boundary wall? And what are they doing to determine why it is beyond the boundary wall at that concentration? And that means it's probably going underneath it. And because and everything in their two-dimensional conceptual site model shows it's not going around the boundary wall. And either it's going through it or underneath it. I'm going to ask the WSDs and EPA to explain why it's there, how it got there, what's the pathway, and what are you doing to make sure that those, we've already proven a pathway goes all the way north. What are we doing to make sure that those chemicals don't, at higher concentrations, don't go north to people? Thank you.
So, Tim Shangra, are you on the line?
Yes, I am.
Would you be able to, in general, answer Tom's question? Because you have a lot of experience with the wells that were put in and at the catcher's mitt and on the site.
Yeah, Tom, I appreciate the question. There's several points to that answer. One is the concentrations that we're seeing that are the high concentrations are located near the north boundary barrier wall itself. And I think you're aware that there was many years that the 1,4-dioxane, well, basically that groundwater was re-injected down gradient to the barrier wall that contained 1,4-dioxane because the original treatment plant did not remove 1,4-dioxane. So it's not surprising that that's there close to the wall. Now that said, there's an awful lot of pumping that's going on north of the north boundary barrier wall. And you're probably familiar with the various areas that are reported in the status reports where the extraction wells are located. Now, I was just quickly going through some numbers. We've pumped many tens of millions of gallons of water over the years from the north of the north boundary in section 31. And as a result, those concentrations have come way down. We're in the 5 to 10 part per billion microgram per liter range in those wells further north. So we're happy to report that the mass of 1,4-dioxane north of those high concentration wells is being reduced significantly to the point where the concentrations that are migrating north of section 31 are in the range that Dr. Berry is talking about that are low enough to not be a health concern. Does that answer your question?
Yes and no, Tim. One is 1,4-dioxane is conservative. That means all the stuff you pumped in years and years and years ago has already been diluted by what you diluted, has moved at the front force or front portion of any water that's flowing or going downstream. And so that 1,4-dioxane is gone. If you're implying that anything just north of the north boundary wall is anything other than new 1,4-dioxane that's coming out at the head of whatever water source it is, in those concentrations, then that doesn't make sense to me with the fact that it's, 1,4-dioxane is conservative and won't bind to anything else. The other is that you just pointed out something that we had concerns of, is the reason the 1,4-dioxane north of the north boundary wall is going down is because you diluted it with millions of gallons of water. And I'm not going to argue one way or another because that's past history. Only if it comes up that you want to pump again would I say that or try to work against that happening. So I think that it's imperative, and I don't know, I would like the technical advisors to explain to me if it's, if I'm wrong, or back me up if I'm right. You've got new 1,4-dioxane coming out from the north boundary burial wall. You need to find the source, you need to find the pathway, and you need to do something to stop it. I know that you're pumping and treating, but you're supposed to keep stuff behind the burial wall.
I don't think anyone is questioning whether the need is there if the north boundary burial wall is not working to make it work. We're all on the same page there, Tom. We're in the process right now of evaluating its effectiveness. We believe that it's working based on the information that we had so far, but we're about ready to embark on a CSC evaluation with groundwater modeling, a fairly sophisticated exercise to assess how effective that wall is. So, we don't disagree with what you're saying. If it's not working, we're going to need to fix it. But if it is working, we have other scenarios that explain why concentrations are still there.
Can you
Oh,
please?
1 second. I want to show a map of the area so we can point out where the extraction wells are along Yale, and so the people can see where this is occurring at. So,
So Tim, I'm asking before Linda interrupted, is that can you please give us those scenarios which would allow us to know where the 1,4-dioxane is coming up in large concentrations beyond the north boundary burial wall?
So tell me where the wells are again, which wells? I didn't write them down as you were speaking.
Well, it's PTP 25, B307, B312. Those are the ones that really stand out to me.
So those walls are right by, just in the shadow of the north boundary burial wall itself.
One's right by it, and the other two are a little north of it.
Yeah, so they're within the area that was impacted by potable water injection. Now, since we
Tell me why the 1,4-dioxane would still be from the potable water injection and still be there.
So let me finish.
Sure.
The potable water, we believe that the potable water injection diluted the plume. We also believe that there is a lot of mass still just down gradient of the north boundary burial wall that now is being recovered. And without that additional potable water that was continuing to dilute that mass, the concentrations are increasing. That's good news. That's good news in the sense that we're able now to capture that mass that we couldn't get to before. So I look at those concentrations as being two things: very localized to the wall, two, being impacted by the absence, the cessation of potable water injection. And as a result, we're seeing concentrations rise. And like I say, it gives us more of an opportunity to be able to recover that mass more efficiently.
Could I ask Dietrich or Eric, Earl, to comment on the hydrogeology or the likelihood of, as an expert, of that being the case?
If I could ask a quick question. First, is there any approximation of the concentration of 1,4-dioxane that was in the water, the injection water in question?
Are you talking about the water prior to 2001?
Yes.
It was probably in the 1,500 part per billion range.
Wow. So it's not similar to what we saw like in the pond samples in 2006 where they were using that water for irrigation.
Oh, you're talking about the Sand Creek potable water or recycled water? No.
Yeah.
This is orders of magnitude higher than that.
Okay. That is just one thing that hasn't been clarified with me. Earl, would you want to answer that question? I mean, how reasonable these assumptions are? You probably got the freshest eyes on the data right now. You may have to unmute.
I mean, they have a lot of data showing these values there at the north boundary barrier wall. I mean, to me, at my 10,000 foot level of understanding and working with the data, they are capturing a lot of it. How much mass of the original mass they captured, I don't know if we had an estimate of that mass, Tim, originally, so that we kind of know from a performance that we've got 85% of it or just 50% of it, and we'll still need to work on capturing that mass. The hydrogeology at this site is extremely complex. I still have a concern about these channels in some of these locations. I'm not sure if the capture is reaching everything there. I know in one of the reports they mentioned the, I think it was the shape or channel geomorphology might be having something to do with the capturability now. So there are performance issues. You know, they're going to look at those things. But like I say, there's a lot of uncertainty. That's what I was hoping we could get at through the 3D VA and maybe the groundwater model to help answer some of these questions that the citizens are raising and to check the performance and make sure that the site is intact with these contaminants.
You know, Tom, I think a short answer is that the north boundary barrier wall is probably serving as designed. It's extracting water that includes 1,4-dioxane, amongst other things. I think really the question is that a 100% solution or is it a 10% solution to the problem? And if things are getting around to it, the significance of that. I think there's still questions about what may be leaving the site and where. And I think that probably one of the best things we can do is look at the data set as it is, or particularly where we have periods of steady state. Because I mean, one of the problems we have now is water was injected, it wasn't injected. All these things are like going back to time zero, especially looking at rate data and trying to determine what's going on. As well as look at how the systems that are set up to contain it meet the geology, like what Earl's talking about. Do they fit into the geology to do their job? And second, are they sized adequately to handle the mass that's coming at them? And I think focusing on those two questions will probably clarify things better than anything else.
So Sarah, can you weigh in on this? I know you spent a lot of time with the containment system evaluation plan and looking at all the data and.
Sure. Yeah, so it just sounds like everyone's touching on it. The containment system evaluation is one of the next steps for the site that gets at exactly looking at Tom's question, but in a data specific way. So that should be responsive. And then as Dietrich said, continued monitoring of that north end monitoring well network into the future is going to provide, I think, some of the best insight post potable water injection cessation. The one thing I wanted to add, Tom, I can sort of, or hearing your description of the thing that doesn't add up, why do these concentrations persist? There's just two pieces to that. And I think Tim sort of touched on it earlier in response to Dietrich's question regarding the mass that is being detected in north of the north boundary barrier wall. And sometimes it's referred to as a lot. Sometimes compared to the source area, the actual landfill concentrations, it is not. The microgram per liter detections don't amount to, I mean, it's a subjective discussion point, but across the country, the different Superfund sites have different categories, and we discuss, common sites discuss common problems. So there is a sort of site category of large diffuse plume, and there's a number of them that are 1,4-dioxane plumes. They're really they can be tricky to know how to navigate them with Superfund sites because they generally persist. And why? Why do these concentrations keep showing up? And that is, as Earl said, or Earl mentioned, the complex hydrogeology, the preferential pathways, where, you know, that's where our focus is as far as transport goes. But in between those is finer grained sediments. And contaminant mass tends to trap in there and then slowly through time release. So especially at these lower concentrations, you see these concentration tails that they just keep going through time. So that's a graph through time, sorry. And getting to concentration 0 is just not a reasonable expectation for for sites in general in a lot of cases. So I think that that's definitely a contributing factor here. However, that concept isn't driving our understanding. We're still asking the question, and we're still, this numerical model, utilizing this large data set, especially when it comes to water levels and the water levels throughout the aquifer. That's a really deep dive into looking at how the flow dynamics occur. And with 1,4-dioxane, that means how the potential contaminant transport pathways behave, because it is conservative. And so the worst case would be where water is flowing, 1,4-dioxane is flowing. Evaluating that, looking at what we know in regards to that, and then saying, okay, well, water's flowing here. We didn't quite realize that. Is that a problem for contaminant transport? That's the next step there.
You know, before we get too far from Tom's question, though, I want to answer another one that you had, Tom, and then come back to what Sarah had to say. We do have some concerns about the exposure point concentrations that are being used in the risk assessment. I think it's going to be very important to look at the area that this data comes from and the time period for groundwater, and ensure that it's one that's protective because of these unknowns about the plume, as well as potential movement. Second, for surface water, kind of the same thing. It's going to be important to determine whether they were stormwater or base flow. Folks are probably not being exposed to a lot of surface water, stormwater, as opposed to the everyday water that's in there that's probably recharged by groundwater, as is typical, we find to be typical in nearby watersheds. So there's still a lot of questions there. In addition, I'll remind you that 46 is the 10 to the negative 4th risk. And anything between 10 to the negative 4th and 10 to the negative 6 is a very important management range. It means this has to be considered in how well a site is controlled, as well as what other chemicals could be adding to that risk. This is a site that has an extensive plume from it. That, again, everybody's talking about uncertainty and questions. So we really shouldn't talk about it as being one that we can consider a 10 to the negative 4 risk. It's at the other end. That said, we do have wells outside of the historic boundary that are very elevated. And so I think that it's going to be important to look at Dr. Berry's numbers, review them make sure they're using some of the more modern factors, as well as what data set this is based on. So I think you're asking some very, very important questions. Now, regarding the tail end to a plume like this, 1,4-dioxane is completely miscible in water. I don't expect it to have a huge reaction with clay like some heavy metals, or to be something that's phasing out of a free product, although it's not impossible for that to be happening on the site. So that's one of the things that kind of clues me in that this is a little bit more than a residual, is its persistence. As a very soluble component, we would expect it to be moving along and going along a lot quicker. So I think I don't want to tie up a ton of time on this because I think a lot of people have questions. I also am going to ask our acting moderator today, Sarah Peters, has some questions about stormwater controls and how they're managed between the state and the CERCLA site. I want to make sure we have time for her questions.
And we do have other questions in the chat from CAG members. Can we go on to those now? That'd be all right?
Yes, and by the way, Tom, great questions. Thank you.
The first one would be, what's the toxicity of the meat in the fish in the pond at Murphy Creek Golf Course? And this would have been back when Dr. Berry was presenting.
We've never sampled the fish out there, so I can't tell you what the tissue concentration might be. And the ponds, at least the 4 ponds that are on the golf course, they're non-detect for 1,4-dioxane.
Can we talk about the uptake of 1,4-dioxane in fish, though? Is that potentially a problem that we know exists, or is that completely enigmatic?
Of the various organic contaminants that we look at from the site, because of its solubility in water, 1,4-dioxane would not be expected to accumulate in fats. But I think that is a great question, and I would put a caveat that I think I would like to see if there's any journal articles to that, because I know a tribe in Maine, I was in a seminar last week, is doing studies on this and other components in their fish stock. So I'd like to double check and get back to you about that.
Thanks, teacher. Okay, so next question is, the future resident is someone who has not lived with this potential exposure previous to today. So where does that put those of us who have been exposed for years already?
I don't know that people have been exposed for years out there, because most of the people who live out there are on municipal water. So I don't think that, I mean, we calculated risks for a hypothetical receptor, but in fact, the city of Aurora has prohibitions against putting drinking water wells in the shallow aquifer. So I don't know that people are actually being exposed to the groundwater and using it for potable sources. People might continue to be exposed, in the surface water, but again, those are low-level exposures and low estimated risks.
The reason for my question was that I live on the fairway, and we get hosed, if you will, by the reused water from the sources of these ponds and other. So I would guess that that's an inhalant exposure. So that was the reason for my question. I'm not drinking the water that comes out of the hose on the golf course, but I do have it vaporizing in my yard. So that was the reason for my question.
Yeah, well, as I said, as near as the data that we have indicates that the water in those ponds, which are used for irrigation, are non-detect for 1,4-dioxane.
Okay, thank you.
Mm-hmm.
Next question, risk assessment methodology has been around for a very long time. Has anyone ever confirmed whether it's an accurate methodology using real data on exposure, receptors, and outcomes?
That's a tough question to answer. Folks have tried doing human epi studies on sites where there's excess exposures, and there's a couple of problems with that, in that a lot of times the onset of adverse health outcome might be years. And that's a difficult thing to deal with. What I can tell you is that, and I can give you an example, and I'll use my my Libby site which is an asbestos site in northwestern Montana. And the risks up there for folks breathing asbestos fibers in the air, the risks were in the range of 10 to the minus 1 to 10 to the minus 2, which is 1 in 100 and 1 in 1,000. And there is a pretty high incidence of mesothelioma, lung cancer, and pleural disease in that community. And it's a very stable community. People are living there, in the site for lifetimes. And the Libby site is the only Superfund site that has actually resulted in morbidity and mortality to the population. So when the risks get really high in that range of 1 in 10 to 1 to 100, it is possible to see adverse health outcomes.
Okay, next question regarding the risk management. Cost is listed as one of the considerations. Does that mean there is some threshold of cost beyond which it is not practical to raise the alarm and take action? In my opinion, this person's opinion, the secure health of humans exposed should have no cost limits. The responsible parties are liable for this threat regardless of how much it costs.
Well, I guess the only way that I can answer that question is by saying that, that cost does enter into the equation as to how much it's going to cost versus how much you're going to reduce the risk. And looks like Steve is ready to make a comment here.
Sure. Yeah, this is an important distinction to make. And the risk assessment process, as David's explained, is designed to come up with an estimate of the magnitude of the risk and then a characterization of that risk. In other words, what does that mean if you have that level of risk? The risk assessment process itself is not bound or constrained by cost in any way. So the numbers are what they are. We then, on the risk management side, in a Superfund context, have 9 criteria. You've probably heard us talk about this before. So a range of things that we consider. Cost is one of those things. It's not intended to be an overriding factor or a determining factor at the onset of that evaluation, where we look at if we, through the risk assessment process, if we've determined there is an unreasonable risk and there is a need for a response action, part of the process of sorting out what that can look like and should look like does include a consideration of cost, but it's not part of the risk assessment. It's after that. It's part of the risk management decision making.
Is that okay, Paula?
Actually, yes. And the question was with regard to it being implemented as a feature of the risk management. Whatever it costs to do a risk assessment, that's beyond. But when it comes down to managing the site as a result of what the assessment is, was why my question prompted. And so I understand, Steve, why, cost is an issue, but in my opinion, you go to the well and you get more money. So I'm just saying
Sure,
that was a concern for me. Thank you.
definitely.
Okay, one more. This question is for Dr. Berry. How were the EPC values calculated? EPA 2014 guidance recommends using COC values, that's contaminants of concern values, from within the main plume with highest values. Appears values used in RA were north and plume fringe values. Please see my shared screen when asked for it. Go ahead. This is coming from Earl.
Well, there are a couple of ways that you can calculate the 95th percentile upper confidence limit of the mean. What we did was we took all the plume data from 2018 and 2019 for the north boundary plume, and basically used either a EPA program called ProUCL or using a statistic program based on R to calculate the 95th UCL. So that's how we calculated the UCL value.
The guidance I'm referring to, Dr. Berry, I guess it's just to get a conservative risk number, recommends that you use 3 samples from the main body of the plume, not just the north boundary expression, but I guess back on the site, if we're just talking about the plume. Sorry to ambush you with this, but it's an EPA document on exposure point concentration calculation.
Well, we used all the wells that were north of the Yale Avenue um, um, boundary. And, those wells, as you go farther north, decrease in concentration.
Yes, that, by the figure
And
1, it appears that you're way on the nose of the plume and using those values for the calculations. The guidance recommends further back where the concentrations are higher in the main body.
well, there's a series of interceptor wells there at the Yale Avenue, so the high concentrations are no longer feeding the plume north of Yale Avenue, as far as I know.
Okay, I mean, it's just a different way of looking at the plume. I guess I'm forgetting that there's a barrier wall that separates high and low concentration. So
I mean, that's what I believe that the barrier walls there or the extraction wells that are right there at Yale Avenue are preventing high concentration 1,4-dioxane water moving further northward. That's my understanding.
This is Tim. That is a correct assumption.
So that's why I used only wells that were north of the Yale Avenue.
So this is probably leftover injectant or matrix diffusion type concentration levels, Tim, you think?
I think so. Yeah, we've got back diffusion going on. We've got, yeah, that's probably the main thing is back diffusion coming out of the soil matrix.
Okay, I just got to adjust how I look at the plume. I'm thinking of a continuous body from the main part of the landfill outward, but I'm forgetting about the barrier wall.
Yeah, and this is Steve. I guess another thought I want people to include in looking at this. The guidance absolutely, it depicts that, and it's an idealized hypothetical, situation where you have a source, you have a plume, and hypothetically you could have receptors all along that continuum. Here, based on the reality of land use and other requirements that are in place, you won't have receptors on the landfill where you have those highest concentrations. So it's a, it doesn't apply directly here because all the work that's gone on over the years, the restrictions that are in place and prohibitions against, certain land uses and things like that. So that's why we took that portion of the plume and looked at that.
I think Earl makes an important point, though. It's going to be important, probably an important refinement of risk assessment calculations when there is some confidence that the shape and what the plume in general is, we have the best idea of the shape of the plume and its location. Otherwise, wells that are in areas that we come to know as being not contaminated could dilute our risk assessment calculations. And I think that's why probably one of the most important parts of any risk assessment calculation, and this one is no exception, are those EPCs. Make sure that they're using data that reflects what's in the plume and not what's going to be outside of it. So I just want to kind of bring up that point because I think there is some application of what Earl is saying. But in both cases, there's probably something kind of in the middle where that applies, but that would benefit the way we think about the plume and how we do those calculations.
I'll just add to that, Dietrich, and Earl as well. You're familiar with the long-term trend of 1,4-dioxane in these plumes, particularly in the wells in Section 31. And we see a dramatic decrease in concentrations in 31. Now we're not pumping in 30, but we're also seeing a similar decrease in those concentrations. So the point is, the trend is coming down, it's not going up. And if you use the concentrations that we have from the 2018, 2019 data set, I think just in and of itself, that's a conservative data set.
Hi, this is Tom Simmons. I was just going to add one other point on that. One of the components that we did include in the risk evaluation was an uncertainty analysis where we calculated the concentrations at the maximum concentration as well. So just want to make that point. I believe those risks ended up being, they're below the mid-range of the cancer risk level.
If we, for instance, if we use the Cmax for the resident, the maximum concentration out there in that in those monitoring wells out there is 7.4 micrograms per liter, and that runs out to a 2 times 10 to the minus 5 risk. So we did do a calculation using the maximum values. We did the same for the surface water as well.
I trust we're going to see a written report on this so we can take a look at the exact calculations and data used. And it might be beneficial to hold additional questions until we have a chance to review that so that we can get to the next topic. Again, to repeat, there's some questions that Sarah Peters has, and I think we need to make sure she has an opportunity to ask them.
Yeah, there'll be a written little write-up on this. Yeah, and the state and EPA right now are working on adding in the VOCs to it.
Yes, and thank you for that segue.
Can we just have one point of clarification for someone who's participating in the meeting? So this one's for you, Tim. You were talking about the potable water injections, and that was north of the northern boundary barrier wall?
Correct.
And that flushed out from, I guess, from your data, large amounts of 1,4-dioxane?
I'm not going to go so far as to say that it flushed it out. I would say that it probably diluted it.
Diluted large amounts of 1,4-dioxane. So this person thought that the water that you were injecting had large amounts of 1,4-dioxane, but I believe that that's what.
Well, yeah. Point of clarification. Before potable water was injected, pre-treated water that contained 1,4-dioxane was injected.
Ah.
Okay, so that's a big point of clarification.
Pre-treated at the water treatment plant there on Lowry.
Yeah, the old water treatment plant.
Correct. Okay, does that answer the question for the person who was asking it? I believe so. Okay, go ahead, Lisa.
Could I get more clarification though on that? I didn't ask the question, but now that it was explained, I have a follow-on question.
Marty,
So,
we can hardly see, I can hardly hear you.
oh, I'm sorry. Is this any better?
Much, thank you.
Okay, great. If potable water was injected many years and it had 1,4-dioxane in it, if the risk assessment was done just using the 2018 and 2019 data, doesn't that mean it's not taking enough 1,4-dioxane into consideration? Isn't it showing a risk that's less than, I mean, it's showing a low risk moving forward, but the question about the people who've lived there for years, shouldn't that risk be a little larger for the residents who've been there a while?
Can I clarify your question? I heard
Sure.
I heard you say that potable water contained 1,4-dioxane.
Yeah, isn't that what was being talked about, that the potable water that was being injected contained 1,4-dioxane?
No, that is not
Okay,
correct.
what was said?
So and I'll give you, from about 1984 to 2001, pre-treated water from the old water treatment plant was re-injected north of the north boundary barrier wall. That water contained 1,4-dioxane. From about 2001 to 2018, potable water was injected north of the north boundary barrier wall. Potable water did not contain 1,4-dioxane.
Okay, thank you.
Okay.
So we have two more points here, or well, actually we have a point and I should say a request, and then there's one person who has two more questions. There's a request that will we be seeing the risk assessment and the conceptual site model together? Anybody?
Linda, you're on mute.
Just from a timing perspective, it's more likely that the risk assessment that Dr. Berry and Tom Simmons were discussing today would come out before the draft CSM is available for public review. But it is possible they would come out at the same time. But you'll be within the next couple weeks to a couple months, they'll both be out. And then Diane McMillan, can you talk about the CSM and what the risk section in that would be like?
Sure. So the conceptual site model is going to be for the entire site, which includes the main landfill area and plume. So before the remedies were put in place, a risk assessment was completed for those media, which means like the landfill soil, the water, the groundwater underneath that area, the surface water that used to be there but is now taken care of, and the sediments. So there was a risk assessment in the 90s that was done. Since then, there have been many remedies implemented to address those unacceptable risks that were found. And those were things like the landfill cover, the institutional controls that stop people from going on it or building anything on it. So my point is that there have been many remedies that stop the exposure pathways. So, you know, you can no longer wander onto the site and touch the waste, those kind of things. So it takes away a lot of the exposure pathways that used to be there. So the risk assessment that's part of the conceptual site model looks at how the remedies have cut off those exposure pathways, how they prevented people from coming into contact with the contaminants in groundwater, for example, or the landfill waste itself. And what it concludes is that there are no longer exposure pathways on the site. Those have all been addressed by the remedies. And then includes this risk assessment that Dr. Berry and Tom Simmons have been working on for the off-site contamination. So the 1,4-dioxane that has been detected in shallow groundwater and the surface water. And so those risks have been calculated because in some cases like the surface water, there is an exposure pathway that is complete. Does that answer your question?
And it looks like it was Karen Hancock's question.
It was more a statement from Karen, and I phrased it as a question.
Oh, okay.
So it was
Right.
more, I think partly just the timing, which is what you answered, Linda. But it would be nice for them to be able to look at the two together. And then finally, we have a couple of questions from Bonnie.
Okay, thank you, Janine. Can you all hear me? Okay. David Berry, I have a real concern about your risk assessment process and your conclusions. And at some point, I would like a discussion about why offsite private wells have not been included in a risk assessment, because we know that there are offsite wells, shallow wells. We've reported them to EPA, and EPA has said that they don't have any obligation to look at these offsite wells. So whether it's the 50-foot well that we turned into EPA 8 or so years ago, or whether it's the wells in Gun Club Estates, any kind of a risk assessment that you are coming up with and concluding everything is safe and fine, it is not satisfactory to the public. And so we need to discuss that. The second thing is that you're bringing in, I guess, Sarah, I think you said that you and Linda have been looking at other Superfund sites, comparing information and data. And I have this question and one other. What other projects have you worked on where they have 138 million gallons of chemical wastes contained? As Tim talks about how the numbers are going down dramatically, you may think that may be good news, but the point is we aren't injecting anymore. So how do we know what's going to happen with those 138 million gallons of chemical waste? And when you talk about looking at other sites to compare to, where do you find another site that's containing 138 million gallons of chemical waste?
Yeah, every site's definitely unique. Oh, I'm echoing. I don't know if somebody needs to go on mute. Every site's definitely unique. However, we do work on a number of different sites, and then we have groups that coordinate on sites across the country, and specific characteristics of individual sites it's definitely worth discussing, comparing remedial approaches, comparing monitoring networks and trends. So yes, Lowry's definitely unique. It's got its own unique situation. And yes, it has similar characteristics such as this large diffuse 1,4-dioxane plume that do apply. There are some applicable situations in other locations.
Okay, well, I appreciate you giving me that explanation, Sarah, but it doesn't satisfy my need to understand why we're hearing that the numbers are going down, and it hasn't been long enough to determine what the impact of ceasing the potable water injection, that we aren't there yet. We don't know, and we got 138 million gallons back there, and they may be heading our way. And I think we need to be a little bit more cautious. And thank you for explaining to me. And I think that anytime you talk with other sites and you compare information, I think that's really excellent. But I do think that other sites could learn about how not to do this kind of thing from Lowry. The second question and the second statement I'd like to make is that the North Boundary Barrier Wall, I can remember in the early 90s when we were Citizens Against Lowry Landfill, and we went in and met with Ken Weishi of the Health Department, and he was talking about this brand new North Boundary Barrier Wall that was going to be put in. He said his only concern was that on one end it was a sand lens, and that they were trying to decide if they could fix that sand lens. And we brought it up on the governor's Lowry Landfill Monitoring Committee and said we were very concerned about this fact that this north boundary barrier wall was it wasn't secure. Well, you know, nothing was ever done about the end where there's a sand lens, and now we know that there's probably 2 different places it's leaking. So it's my contention that we're having things come under that north boundary barrier wall, and this is probably what's causing the plume. And I say probably because that's my suspect. But if you've got 138 million gallons of chemical waste behind that barrier wall, and it's full of all the chemicals that would be indicated by 1,4-dioxane, my concern is that the leakage under the north boundary barrier wall has always been the cause of the plume. And as the chemicals do their thing, we're going to have more dioxane coming down the path. And I don't think we're doing much to prevent that. And so I'm just really concerned that we're talking about how the numbers are going down, but we have no real indication. In my opinion, if you shut off injecting or dumping this water years and years ago, we shouldn't have any more coming down. That's my personal opinion. And so those are my 2 concerns. Are we ever going to get to a point where we correct what's wrong with the north boundary barrier wall? And we find out if that's where we're getting this leakage? And secondly, are we ever going to find out if private wells have been impacted by all of these chemicals coming down Murphy Creek and in the plume for all of these years? And I know no one wants to find that one out, because then somebody's going to have to replace water. But you know, that's a reality. And if you're going to do a risk assessment, you have to figure those things out. So those are my 2 questions.
So Sarah, can you talk about the numerical model in the containment system evaluation and how it'll look at the north boundary barrier wall to see what's happening at the wall?
Sure. I mean, it's a big topic, and probably could use its own presentation so that you can, and I think we have sort of provided a PowerPoint a number of months ago. So maybe you can recall the particle flow maps that we had up there. Essentially, the numerical model takes the water level data primarily from across the network, looks at where those water, how deep those, what section of the subsurface those correspond with. And from that, CDM Smith has built a 3-dimensional finite element numerical model. Sorry, I know that that's starting to get away from an actual explanation, but it looks at, okay, if a particle of water is here, based on the water levels around, knowing that water is going to move from areas with more water to less, where will this particle of water move and approximately how fast? So to be able to put that level of analysis in around the north boundary barrier wall in 3 dimensions, we can evaluate where a particle of water might be moving that does not indicate capture is occurring. Then after looking at those results, we can see, okay, well, this area, you know, we might have concerns about how well capture is occurring. And then that area can be evaluated to determine whether or not that corresponds to contaminant transport. And if it does, next steps can be evaluated, such as optimizing the performance of the extraction systems or the barrier systems in that area.
And then Bonnie, to your question or statement about private wells and looking at those. So EPA did hear the community request for that. It was assigned to our site assessment team. So that's separate than what Lowry Landfill's under. Lowry Landfill's under our remedial Superfund program. So the site assessment team works through the state of Colorado. So that's been assigned to the state of Colorado, and Colleen's on the line. I don't want to speak for the state, but I know that a site assessment effort is occurring. No final determinations are made. And Colleen, do you want to say anything about that?
Yeah, we're still looking at that. The process kind of got stalled a little bit due to COVID primarily, but we're also we need to finalize what we call the preliminary assessment first, and we're trying to get some additional data that we've been waiting for from some of the other sources in the area before we can finalize that. That preliminary assessment document would then go to EPA's site assessment team for review. And once that's done, then we come up with the sampling and analysis plan for any samples that we're going to collect. So everything did get stalled a little bit by COVID. We can actually, at this point, don't have a mechanism to go out and sample private wells because of the COVID restrictions. So even if the plan was ready to go, right now we aren't going into people's homes. So I'm not sure when that's going to change. And so that's something we're evaluating. But it's not just this site that impacts. There are other sites where sampling for other contaminants, whether that be indoor air or lead paint or things associated with the smelter, need to be sampled. We are not going into people's homes right now. So that's really complicating the progress.
I understand that, Colleen. Thank you for that explanation. It makes sense. However, I would like to know, has anyone responded to the 4 people that contacted EPA?
Not at this point. We're waiting to determine what's going to happen with site assessment, because we were hoping that there would be, before COVID existed, that we would have an answer sooner. So it's just been delayed, as a lot of things in our agency has because of COVID.
I think that's rude. I really think that's rude. It's been a long time, over a year. And it would be good if you want the people to trust the agencies need to learn how to communicate. And so the only people that have been communicating with them is the CAG. And what can we tell them? Because we don't have any authority. So it would be good if these people were kept up to date on what's happening, why nobody's responding. And yes, we're still thinking about you, and we will be in touch, at least.
Noted.
Well, we have one more question. We're really gobbling up time. We're almost to the end of the meeting, so we might as well regroup after this final question. And it's from Sarah Peters. Do you have questions, Sarah? Sarah Peters, you may be.
Yeah, struggling with unmuting. I'm sorry I don't have video. My internet is struggling today. I do have questions, but they're related to the stormwater management, and I was hoping to get to that presentation. Tim, do you have an idea of how long that presentation is going to take, and if we'll have time for questions following that?
I could do it in 5 minutes, or I could give you the whole enchilada in 25 minutes. Which would you prefer?
Let's do the 5 minutes, and then we can jump into some of my questions, if that's okay.
That sounds fine.
So Tim, would you like to share your screen and launch into that then?
No, we only have 7 minutes left.
So can you see that?
Yes.
I'm trying to bring up the slideshow itself, but it's not letting me.
So what I'm really interested in is, having reviewed the 2008 document related to stormwater or surface water management and monitoring. It leans into stormwater management And I'm wondering if that's still the current management program. It appears to be, given other reports that I've just jumped into the most recent O&M report, and it references that document. Is the site still sticking to the fact that Superfund sites are exempted from regulatory compliance under the stormwater monitoring plan? I mean, the regulatory authorities compliance, not that they don't have to meet compliance.
No, I don't know where that came from. The Superfund site is always obligated to comply with the substantial requirements of the regulations. So the stormwater monitoring plan that we're following complies with CDPHE regulations.
Okay, and it was unclear in that document how that fits into the overall surface water management program. It cites a number of documents, of other documents that are related to surface water monitoring, but it doesn't bring them all together. And there are components in there such as monitoring this, the surface stability of the caps and other areas that are maintained generally on the site, but they're not incorporated into that 2008 document in a way that brings it kind of comprehensively together of how is surface water managed on site. And
Can I address that question?
Yeah.
I know we're running out of time, and I don't want to cut you off, but go to slide 8. I've got this up in front of us.
Mm-hmm.
So the stormwater monitoring plan has two parts. One is the stormwater management, and the other one is the monitoring program. The stormwater management component references the existing O&M manuals that are in play and required for the site. So let's go down the list. Covers and stormwater O&M.
Well, I can
manual.
read the list. We don't need to go down the list. I don't think. Sorry.
Okay. Well, my point
is
is that by reference, all of the existing plans that cover maintenance of stormwater ditches, that cover maintenance of covers, are all embedded in the program.
Well, they're referenced
as required
in the
by the
document.
state, as required by the state regulations.
I would say that the state regulations require that you build into your stormwater management plan how those are being managed, and I feel like that's missing, which is creates a struggle when trying to understand how stormwater is being managed on site. The other,
I think the problem we have here is that Tim, we ran out of time for Tim to present his presentation about stormwater management. And I think jumping right into questions is not really fair to the rest of the group. So unfortunately, I think we have to push this to the next CAG meeting, as we seem to have to do with all of our meetings. But these are complex issues that we all have to talk, that take a lot of time to discuss. So if everyone is amenable, I think we should push this forward to the next CAG meeting, and apologies to Tim that we did not get to your presentation. Do we have any other opinions about this?
And I was this is Linda. Sarah, if you have specific questions that you would like answered sooner, if you could send those in writing to Lisa, and then we can get a response back to you quicker than waiting for the next CAG meeting.
Linda, this is Bonnie. I'm glad you offered that, and I would like for Sarah to do that. However, I think her questions are very pertinent, and I want to make sure the entire CAG is able to hear her questions and the response. So if the questions are answered, I would request that the questions not get lost in the shuffle, that they're shared clearly at the next meeting.
Absolutely. it's easier us to answer questions if we have them ahead of time too. So yeah, whatever you would prefer, Sarah.
I'm following Bonnie's lead, so I can draft these questions up for the CAG.
So is this an indication that we could possibly start the next meeting with this subject, or, you know, the CAG has submitted and I'm just wondering if, you know, we got a lot of work that we need to get done and we're always behind. I would have really preferred that we talked about these water issues and things tonight. And, you know, so I'm asking if we can have this stormwater issue starting out next time, and we need to get on to the subject too of DADS, because we believe that's a really important part of managing the site. And so, Linda, I would really appreciate your consideration of what issues the CAG really needs to talk about, because they're pertinent now.
We'll put it on the list for the next meeting. Yes.
We appreciate it. Thank you. And I would like to, since everything's quiet right now, darn it, I want to express the CAG's thankfulness that our technical advisors are here tonight, because we were told by EPA, because our funding has run out and it hasn't been replenished yet, that we could not have our technical advisors on board. And I want to thank them for being here. And I need everybody to know they're very special people, because they didn't want to charge us for tonight, but we had enough community investment for our funds. We have enough to take care of them because they're very valuable and we don't want them to get the shaft. So I want to thank all of them for being here tonight. Their input has been valuable.
Okay. So that just leaves us with the closing. Basically, the next CAG meeting is September 17th. And we will prepare that packed agenda yet again and work our way through it. So thank you all for your patience. And I think we had a lot of good Q&A after the risk assessment discussion. So I appreciate that. Anyone else? Final words?
Thank you,
Okay.
everyone. We appreciate your time.
Yep. Thank you.
Everyone be safe and be well.
Yes.
Thank you.
Bye all.
Bye.
Thank you.
Thank you.